Hi everyone, let's get started with the first video of this series, which I am starting on chapter 2. As I said, for some reason, I by myself don't know for what reason I'm choosing it. I just happen to be liking it polynomials, so I started actually with polynomials. All right. Okay. So according to the textbook, what is inside the chapter called polynomials? It is the introduction to the polynomial as usual. Then there is something called geometrical meaning of the zeros of a polynomial. Then relationship between zeros and coefficients of the polynomials. Then finally we have division algorithm for polynomials, and we end up the chapter by the summary of the chapter. Okay, fine. So first things first, let's answer this question of what is a polynomial. Okay, fine. The polynomial is not a new thing for you. You have actually already done it in your ninth standard. If you might have done it a little curiously. Even otherwise, I don't think so. Actually, anybody would have missed that particular chapter. Now, polynomial is kind of small expression. It can be in of one variable or two variable or three variable, etc. Okay. The way we usually write here is simply write p of x is equal to, let's say we write it as x square plus 2x plus 2, and this is a polynomial. Now what we have done here is we do have one variable over here which has a square term, and another variable, and actually the same variable but which doesn't have square on it. That's all, right? So this particular expression is going to be called as a polynomial. Now you can see that the left hand side has something called p of x. We call this as a kind of notation to represent that expression. So all that it says is p is a polynomial in the variable x. So that's all it says. Okay, fine. So some people would like to represent this by a letter called y, or even some people would like to represent this by y of x, etc. So it depends. It really depends on what context you want to work with and what you wanted to work with. All of them. Fine. Okay. So because we have expressions like this, because we have same variable appearing in multiple times in the terms, now we can actually categorize this kind of polynomials. For example, if I have a polynomial with nothing on top of it, in other words, there is one on top of it with the variable x, then we're gonna call this polynomial as a linear polynomial. Suppose if we have similar polynomial like x square plus 2x plus 3. Now what we have here is we have a power term which is 2 on top of it. So we're going to call this particular polynomial as a quadratic polynomial. Quadratic polynomial. And similarly, suppose if we have a cubic term, in other words, if we have a powers is x cube plus, let's say, 4x square plus 2x plus 3. Now, what is this polynomial is? You see here the highest power which is appearing on the variable is actually 3 over here. So we're going to call this particular polynomial as a cubic polynomial. Now we can of course go ahead and call biquadratic all of them. I don't even know what is the quadratic polynomial for degree 5 or etc. I by myself have mentioned the word called degree, right? Now to generalize this, if suppose the power is 4, if the power is 5, all of them, what we do it, right? So now we have a small way of actually telling it. Now any linear polynomial what we have here, we're going to call using a number called degree. Now how do we degree is being first of all calculated? You see a polynomial over here, the number which is appearing on the power of x. Suppose if it has only one x and whatever the power of x, and that is the degree of that polynomial. So here we're going to call this degree of the polynomial is actually 1. Now here you see here also we have a degree. In other words, here also we have a power, and here also we have a power. Now what we do as a degree is we're going to take the highest possible number which is actually sitting on the x. So here is the degree is 2 because the highest possible number which is sitting on the power of x is 2. So similarly here, you see here the power 1, here the power 2, and here the power 3. So the highest possible number is 3. Therefore, we're going to call the degree of this polynomial is 3. So similarly, if you have a polynomial with the power is 4 in it, then the highest number is 4, and hence we're going to call that polynomial as a degree 4. So any linear polynomial is going to be called as a polynomial with degree 1. In other words, a polynomial, let's write it here, the polynomial of degree 1. Now similarly, you see any quadratic polynomial will be always having the polynomial will be always having the degree 2. So we're going to call this as a polynomial of degree 2. Okay, degree 2. And similarly, this is actually is polynomial of degree 3, right? So this is a polynomial of degree 3. So similarly, if you have another polynomial, let's say suppose 4x to the power 4 plus 5x cube plus 5. Now you see x square term is absent, x term is absent, but that's okay. All that we wanted was what is the power sitting on x and what is the highest power sitting on x. So here it's clearly the highest power sitting on x is 4. So we're going to call this polynomial as a polynomial of degree 4. So this is a polynomial of degree 4. Note that I have actually used a small simply written as poly, but I have mentioned as polynomial. So make sure when you're taking notes, you're writing it as polynomial instead of poly. All right. Okay. So that's about a small introduction about polynomials. So this is what actually we have learned so far. Now one more polynomial I wanted to introduce along with that is what if there is no x term present. In other words, what if the x term is completely absent? Now that particular thing will be usually mentioned as a constant polynomial. Let's say we present only simply 5. We don't have anything else on it, right? There is no x terms in it. Then we are representing this as a constant polynomial. Now we also have to offer a degree for it because we have discussed about it, right? All that we wanted was a degree to represent any polynomial which is on higher orders. So a constant polynomial, as you might have noticed, we could call this as a polynomial of degree 0. That's it. Hopefully that makes sense. All right. Okay. So that brings this lesson to a close. In the upcoming lesson, we will actually see what is the 0 of a polynomial. First things first, I also wanted to say one more thing. I forgot to say that. Now we also have seen that what is a polynomial here. So these are the polynomials. Now, what are not polynomials? So I also wanted to give that examples. I forgot completely about it. So what are not polynomials? Very simple definition. Simply, if suppose you cannot write it in one of these format, whatever I have mentioned over here, then that is not a polynomial, right? For example, you see 1 divided by x plus 1. This is not a polynomial because I cannot write it as x to the power something plus something because it's actually in the denominator of something, right? So I can't do that. And for example, I cannot have a power with rational numbers. So you see this particular expression that whatever I have written over here could have been probably written as x to the power 1 by 2 plus 2, and that doesn't mean that I am having power on x and so it can be considered as a polynomial. No, it's not a polynomial still. That means I'm expecting an integer power in it, right? Fine. Now similarly, if you do any polynomial which is on fraction, or if you say suppose sine of x square plus 2, again this is not a polynomial. You see here I am not having only x square plus 2, I am having sine of x square plus 2. So this is again not a polynomial, meaning it is not, it cannot be written as sum of the terms which is involving only x and x square, right? Okay, so as at least now, fine. Now that means, is there any general definition of a polynomials? Yes. So let's write that. So general definition of a polynomial. Simple, any expression which is of the form a0 plus a1x plus a2x square plus and so on, plus an x to the power n is a polynomial. Okay, let me introduce a new page here. Yeah, so that is a polynomial. Now, specifically, we will call this as of degree n if the coefficient of x to the power n over here is not equal to 0. Remember, if the coefficient of x to the power n, which is an, suppose if it is equal to 0, then what will happen? This term will vanish, right? So make sure that the coefficient of coefficient of x to the power n is not equal to 0, and hence we can confirm that that is a polynomial of degree n. Okay, so if an is not equal to 0. Okay, fine. So we also would like to represent this as some p of x, as I have already mentioned. So this is to say that this is a polynomial with respect to the variable x. That's all. All right. Okay. So that brings this particular lesson to a close, and I will see you in the next video with the zeros of the polynomial.